Hi everybody, welcome to the last video. This is going to be the last tutorial that we have for virtual school biology, and I'm going to carry you through it, and it is on conserving biodiversity. Quick reminder of what biodiversity is. It's the different types of living things in any given area, and one thing that I hope you've gotten at this point is that biodiversity is good, so conserving biodiversity is good. Some places are blessed with an unbelievable amount of biodiversity, and some places, don't have so much. In either situation, you want to conserve it because the places that have a lot of biodiversity need a lot of biodiversity, and the places that don't have a lot of biodiversity need all the biodiversity they can get. So, we're going to be talking about ways in which we conserve biodiversity. Sorry about that. And some science that has gone into it, and a lot that we've learned about biodiversity in the last about the last 100 years. So let's get started. The objective here is that you're going to use evidence and scientific reasoning to choose the best solution to a biodiversity problem. There's lots of solutions, and not every solution is 100%. There's no 100% good solution, and not every solution works in every situation. What works here may not work over there. One of the things that, if you're going to conserve biodiversity, is you have to monitor the population. So there's all kinds of things that can affect the population, and one of the things is if you have an ecosystem, you need to be monitoring as many populations as you can. If you have a population that you're concerned with, such as a bird or a frog or something like that, then you have to consistently monitor that particular population: bird, frog, tree, fungus, right? There's lots of ways we do it. I'm going to show you a couple of examples. This is the Panamanian golden frog. It's an endangered species, and so the scientists monitor populations for many reasons. One of them is to get an idea of how many organisms there are in that particular population, and to know if its ecosystem is being threatened. Another one is it gives you an idea of the health of the ecosystem. And we might even find things that we've never seen before by monitoring other species. Frogs especially, because their skin is porous. They breathe, but they also breathe through their skin, and lots of chemicals pass across their skin. So if there's bad stuff in an ecosystem, frogs are going to be the first things to tell us, right? So if the frogs are this is just an example. But if this golden frog, is endangered, then we're going to know that. Sorry about that. We're going to know that by monitoring it. Now, how do you do that? There's all kinds of ways. I've been involved in monitoring the alligator population on Lake Okeechobee for a couple of years. Haven't done it in many years, but I did it. And it was a pretty simple thing. You go out and you hop on an airboat and you go ride around and you count the number of alligators. But gators are, hard to find, so you have to do it late at night so you can shine a light and see their eyes. And you have to go with somebody who knows what they're doing, a professional, because you have to very quickly tell how big the gator is and what numbers there are. And it was a pretty challenging thing, but we did it. So we're going to be talking about some methods. Sometimes it's not so easy as hopping in an airboat and just driving around. Sometimes you have to really go do some difficult counts. There's another one, the Kissimmee Prairie Preserve State Park, is working on conserving the population of Florida grasshopper sparrows that live there. And the thing is that how do you know how many grasshopper sparrows there are? And how do you know, because there's another one out there called the American grasshopper sparrow that looks an awful lot like it, and how do you know which is which? Well, you set up these big nets and you drive the birds into the nets, and then you catch the birds and you decide and you count and you tag and all this stuff. So there's lots going on. Okay, now take a look at this. It took me forever to even decide this was a bird until I read the bottom. I thought it was a snake. And that's how camouflaged it is, and that's how that's another thing that creates some issues for scientists. Sometimes the organisms live in remote regions. Sometimes the organisms are trying to hide from you. They don't want to be seen. Sometimes they're difficult to see because they move so fast, or they live deep underwater. I mean, there's so many challenges to monitoring the population of organisms. And so scientists work to overcome those Couple of ways that we do it. We're going to start with canopy fogging. Canopy fogging uses a low dose insecticide. It doesn't harm other plants or animals, but it does kill the insects that live in the trees. The insects fall to the ground, you pick them up, and you count them. You can collect and count quite a bit of the number of species of bugs that live in the canopy. And I know what you're thinking. You're thinking, wait a minute, we're trying to conserve these things? Well, yeah, but we're really trying to conserve the ecosystem. The bugs will take care of themselves. So if we kill a few bugs to get a good count, it works out. And there are disadvantages. I mean, you're putting a chemical in the, chemical poison in the ecosystem. You may be spraying here, but the wind takes it down there and kills a bunch more. There's all kinds of problems. I don't think this is a good idea, but there are people that do it. It works. Netting is an interesting one. This is absolutely one of the best things to do because it usually doesn't hurt the animal, scares the heck out of them. It doesn't hurt them, and you can actually get very close and do a lot of work. Like when we were doing the grasshopper sparrows in the Kissimmee Prairie Preserve, we would actually we had a biologist that was trained in how to hold them without hurting them, and you would tag them and measure the length of their beak and how much they weigh and all kinds of things, and then you'd actually draw some blood. So I mean, there was lots that we could do by netting these animals. And you can net birds, you can net bats, you can net bugs, you can net small rodents on the ground. So that's a pretty good way of doing it. Point counts are a little bit easier because you just stand in one spot and you count, and you come back later and you stand in one spot and you count again, and then you have a little formula that helps you figure it out. What's really nice about point counts is they're easy. One guy can do it. It's not like a search. You walk to a spot and you stand there for a specific amount of time, and then you count. You may be counting birds, you may be counting bugs, you may be counting trees, but you stand in at one spot and you turn in a circle and you say, how many can I see? And if you can't see it, you don't count it. And it really helps because you got to be consistent when you do these things. You may know there's one over there, but if you can't see it, you don't count it. That's the rule, right? So point counts are easy. One of the disadvantages is that you only see in one small part of the ecosystem, but we then imply that what is good for this part of the ecosystem is for every part. All these have goods and bads, right? Area searches are a little bit more interesting. This would be similar to what I did with the airboat, because in this case you're kind of walking through the canopy, whereas with the airboat we were driving through the lake. But you walk through and you count, right? And the good news is that if you're trained in it, you can get a pretty good idea for what's there. There are people who are trained in whatever birds or butterflies or alligators or whatever you're looking for. The bad news is again, you normally don't do the whole area. You do a small part of the area, and then what we call imply or infer that what applies to this area applies to all the areas. It generally works. It gets you within 1 or 2% of the actual number. Quadrant sampling is good if you're dealing with small structures or small areas, like you make this quadrant and it's supposed to be 1 meter by 1 meter, and then you count, what do I see in that meter? If it's here, you don't count it. Only if it's inside do you count what's in that meter square. And you can go take this quadrant all over the place and throw it out, and that's it. And that's actually a very useful way of sampling, because it gives you the same number or the same size every time, and so when you do that in counting, it's an accepted form of sampling. I've seen people actually make these that float, so they go out onto a waterway and throw that out, and then they only count what they see directly underneath the floaty part. You can make these big. Some people make quadrats that are a little bit more of a theoretical thing, where they're like on a GPS, so you stay inside of a 1 kilometer quadrat. But you're talking about something the size of the ocean, for example. Most of the time, quadrats are not really effective for organisms that move across wide areas. You're looking for organisms that don't move much. But again, it's a method that's very useful. None of these are perfect. Okay, transect sampling is where you have a whole area to cover, but instead of covering the whole area, you just draw a transect. So you move from one side to the other, and then you move over 100 feet, 1,000 yards, 2 miles, whatever, and you go again. You could think of this as like Lake Okeechobee, and you could draw these lines that are parallel to each other, and you would cover, the entire lake, you would definitely be missing a lot in the middle. But the idea is that when you do this transect, you're getting a pretty good idea that you then again infer or imply to the areas that you're skipping. You can miss seeing some individuals, you can miss seeing a lot, but it is an accepted way of sampling, and the math has been adjusted to where you kind of count for the areas that you miss by making some assumptions. And assumptions, statistics is full of assumptions, but doing population counts, it's rare that you can count every single thing in the ecosystem. You have to figure out ways to sample smaller amounts of the ecosystem and then kind of multiply that by what you suspect is there, or infer that what you see here actually goes here too, and the math works out. One final way is that you tag and track, and we've gotten very good at tagging and tracking things, especially the highly endangered organisms. They get shot with a tranquilizer dart, or they get like sharks and stuff. They just find them and stab them with like a little harpoon that holds it in there. It doesn't even really hurt them, but now they've got a tracker on them. And so getting these trackers, we even put them on birds so that we can monitor what's going on with them. Some really effective things, because it gives us, we don't have to stand here and watch the animal the whole time and monitor how they're traveling. That would be very difficult. Instead, we can just stick a GPS device on it and monitor it as it flies from North America to South America sometimes. So it's good for giving us some ideas for how individuals behave. It's not good for tracking large populations of organisms, but it has some advantages. And those GPS devices, if built right, can last for years. And it's so cool because we've got a lot of aquatic organisms, a lot of fish, whales, that sort of thing that we've tagged, and you can actually go to websites and see them. You can see where certain great whites that we know of right off the coast of Florida all the time. They even got names for them. Turtles, we do it with turtles too. So after we track these populations, one of the best things that we can do after we identify these populations and start keeping an eye on them, one of the best things we can do is to try to conserve the ecosystem. Whenever you hear the word conservation, most times people think, oh, we're trying to conserve the yellow-billed duck or the funny-scaled fish. No, we don't really focus on us species, because that doesn't work. What you really have to do, you can in extreme cases, but the best thing to do is to focus on making the ecosystem that they live in healthy so that they'll thrive. And for instance, the state park that we have north of town, it was established to create a healthy ecosystem for the grasshopper sparrow. Now, normally healthy means go back to the way it was before humans got involved. And when humans came here in the 1800s, they took that place up there and they turned it into a cow pasture, which was really useful, except that it turned out that it was a very rare type of ecosystem in there called a dry prairie preserve habitat. And so it had to be burned. It had to not have that many trees in it. It was more of an open prairie. And the birds that lived there, the grasshopper sparrows, had evolved to living in that type of an environment. And so as a result, when you change that environment by not letting it burn, or by disking up the palmettos and letting it go back, or you're turning it into grassland for cows, you're really changing the ecosystem for the bird, and that causes them to struggle. So if you want to conserve it, the best thing to do is make it go back to the way it was. Now, that Kissimmee Prairie Preserve State Park was privately owned by the Latmaxi Corporation, and they got bought out by the state of Florida. The state of Florida had a lot of money in what they call a mitigation fund, and they bought that land up there with the intention of turning it back into the way it was. Lots of controversy regarding it, but it's working. The grasshopper sparrows are coming up. Their habitat is being reestablished, and they are growing. So that's what we mean by conservation efforts. Rarely do we worry about working on a single species. Instead, we may be worried about a single species, but what we do is we repair their entire ecosystem so that they thrive. And when they thrive, the other members of the ecosystem thrive. And it's usually way more than just one organism. A lot of times we're talking about a whole group of organisms. Okay. When we talk about conservation, one of the first things we have to talk about is consumption. Forests and coral reefs and freshwater lakes and you name it. Ecosystems have stuff they provide humans, and we consume from these from these ecosystems all the time. And so the thing is sometimes we consume too much. And by consuming too much, the easy one to think of is trees, lumber. When you cut down a tree, you are destroying part of a habitat. So instead of just clear cutting a forest, are there other ways that we can harvest trees from this ecosystem without doing a lot of long-term damage? And as it turns out, we've learned over the years that sure there is. There's tons of ways we could do that. How about the water? How do we keep the water clean so that it's usable by everybody rather than one individual polluting it and ruining it for everybody else? So let's take a look at some ways of conserving natural resources. One of the best ways to conserve natural resources is to focus on the renewables. Instead, we use a lot of non-renewable resources, the fossil fuels, and we're going to run out. Plus, there's some evidence that burning fossil fuels is changing the climate. So one of the best things we can do is start looking at renewable resources. You know what these are: wind, solar, hydrothermal. The problem with all of these is that they are still fairly young. They're fairly expensive. Gas is way, for energy produced, gas is way cheaper because we've been, our infrastructure, our highways, our delivery systems, our cars, everything has been kind of designed around cheap gas. But there's a huge effort in the last 40 or 50 years to switch to non-renewables, and switch to renewables. Now, the problem with them is they each have their own issues. For instance, wind can produce some amazing amounts of power, but it's not for everywhere. For instance, you can't have a wind farm in Okeechobee because we just don't have consistent high winds that are enough to merit putting up a turbine. So we don't see these in Okeechobee because we don't have it. What we do have is a lot of sun. Okay, so we can talk solar in a minute, but one of the problems is these only work in certain places. The other one is, let's be honest, they're kind of ugly. I mean, I think they're kind of cool looking, but I don't want to look out, sit on my back porch and watch the sunset through the windmills. They're noisy, and as it turns out, when they're spinning at night, birds that are migrating at night can't see them and smack, and every day they go to the bottom of the tower and they pick up dead birds. So there's lots of things going on there. And that's just one. Hydrothermal or hydroelectric dams are another one. Building a dam can create an incredible amount of power. In fact, the entire city of Las Vegas runs off of hydroelectric power. Pardon me. But the problem is when you build a dam, you raise the water behind it, destroying habitat. You lower the water in front of it, destroying habitat. You control how much water flows down it, so wherever that water eventually ends up going, there's less water flowing down there now, so that has an effect on it. So, again, it's a great idea, but it has an effect. Solar is a great idea, except it takes a lot of certain rare earth minerals to produce solar. Solar is expensive. It's getting cheaper. It's actually getting to the point where solar makes sense, and solar is starting to really make sense for us here in Florida especially, but solar doesn't work all around the world. It only works, relatively close to the equator. And it takes a lot of solar panels. Like here in Florida, one of the biggest things we need is air conditioning. Well, in order to have a solar-powered house run an air conditioner, you're going to have a lot of solar panels, and it's still expensive. So things like that have their costs, have their disadvantages. It's still easier to have the power company deliver electricity to our home. It's far less expensive. So, we're not quite there yet, but we're working our way towards it. We're getting to the point where it may be, like if you had to build a new house today in rural Florida, it would probably be cheaper to run solar than it would be to try to get electricity to it. There are situations in which solar makes sense, and we're getting closer and closer and closer to that. Sustainable resources are things like stuff that will come back very quickly. A tree is sustainable if you cut it down and plant a new one. Now, here's a situation where if you cut down all these trees, you just destroyed this entire habitat. So, okay, you got your trees, you got your paper, you got your lumber products and wood products, and even if you replant it in here, to grow again, which is what you're supposed to do, the problem is that you've really kind of wrecked anything that lives here. Even it really has an effect for anything that's left over there in that tree, in that forest. So there's lots of ways to cut trees that aren't necessarily going to totally destroy the ecosystem. Instead of cutting down every tree, what if you came down and cut every 10th tree, and you did that every year? And hopefully by your trees grow fast enough that 10 years from now, the ones you planted that first year are fully grown and you can cut them again. This is called selective cutting, and it's it's done all the time. But sustainable resources are where we have to replant or reseed or something like that. And it's a good idea. It's better than just clear cutting it and then leaving it. And then clear cutting and leaving is happening in the Amazon like crazy, and they're really doing some amazing damage to the ecosystem down there. You guys know about recycling. The thing is that back when I was a classroom instructor, I did a really neat project one time where we went to the lunchroom after lunch and we grabbed a bag of garbage and we took it back to my classroom and we laid a big tarpaulin on the ground and we just kind of dumped the garbage out on the tarpaulin and started sorting it. Can this be recycled? Can this be recycled? Can this be recycled? And the funny thing is that one bag, and they must have made 20 of those bags a day, every day of the week, but well over 80%, almost 90% of what went in that bag could be recycled. And we don't do it. It's just easier to throw it away. But we could recycle. It's something that we can do. We can recycle our plastic bottles, our glass, our paper, our food. Okay, and think about it. What else is in there? If we recycle the plastic and the glass and the paper and the food, how much is left in a garbage? Usually, think about the garbage in your house. What you throw into it. The paper is recyclable. The plastic's recyclable. The glass is recyclable. Why aren't we recycling? Recycling is a huge thing going on, and there are companies that see the value in recycling, and so there are a lot of companies that are spending money to further this technology because they know that that bottle actually represents refined material that could be used for something else. I've seen them build park benches. I saw this lady the other day on Facebook. She invented a way to turn this into like concrete blocks that last longer and are tougher than concrete, and they're made out of entirely recycled plastic. I hear that they're going to start putting some of this stuff, once they shred it up, they can put it into the material that makes roads, and it makes it stronger. We just have to have the knowledge and the ability to investigate, and the next thing you know, this recycled stuff is very useful. And the first recycled was obviously aluminum cans. Aluminum cans are the easiest thing to recycle because you just take them, throw them back into this big hot boiling cauldron of metal, and they melt right in there. And then you can turn them back into something else, like a can or a jet airplane or something. We know how to recycle, and we're learning more and more about how to do it better all the time. The problem is that it starts with the person throwing the garbage away. And if you don't have a recycling system set up in your house or in your classroom or in your place of business, then it doesn't get recycled. It just all ends up in the landfill. So something for us to work on is recycling. It works, but we got to get it better. One of the big things that we do is that we take a piece of land and we say, okay, this piece of land is, for some reason, there's something about it we want to keep. So we buy it as when I say we, I'm talking about the government, on behalf of the people. We buy this land. This is Zion National Park in Utah, I think. It's a national park. This is one of the few I haven't been to. I'd like to fill that in soon, but you can go to Zion National Park, and you, as a citizen of the United States of America, have a right to visit this park and to take a look at its beauty and also what it's there for conserving. There's a lot of things that live around this area, including what's inside of the park. A lot of trees, a lot of animals, and a lot of, the geography has to be conserved too, because this is all unique. It's not found anywhere else in the world. And so as a result, we draw a line and we say, you can't, on the other side of this line right here, you can't go develop, you can't go build a house or farm the land or anything. We're going to leave this to where it looks the way that it looks because it's got a natural beauty to it. It's got a lot of species that live there that are being threatened, possibly even endangered, and we're going to spend some money monitoring them. One of the most famous national parks, of course, is Yellowstone National Park. And Yellowstone National Park is famous for lots of things. It was the first national park set forth by Teddy Roosevelt back in the 1800s, but also wolves, the farmers around Yellowstone were like, look, we we're trying to farm here. We're trying to raise baby calves, and these wolves come in here and eat our calves all the time. And back in the 1800s, the solution was, we'll kill all the wolves. And as it turned out, that was a bad thing. What do you mean killing wolves is bad? Well, killing wolves is a bad thing because now the things that the wolves eat started growing out of control, and they started consuming the resources that they consume a lot, and it was putting a huge stress on the ecosystem. And as it turns out, wolves were a really important part of the ecosystem, so they went up to Canada and found a couple of wolf packs and brought them back to Yellowstone and released them, and that was about 20 years ago, and now we're starting to see a huge improvement in the entire Yellowstone ecosystem. And sadly, sadly for the farmers, but the farmers on the outside of the Yellowstone Park, they've just got to deal with it, because just because you want to raise calves and make money doesn't mean that the ecosystem should suffer. So we buy land, whether it's a huge piece of property like Yellowstone or a smaller piece of property like the Kissimmee Prairie Preserve State Park. That's still the point, is we buy it and we conserve it. Here's another thing, humans do all kinds of stuff, and how do we, is there a way that we could build a road or build a house or build a condominium or a Chuck E. Cheese or something without being as damaging to the environment? So this is a passageway under a railroad track, in which I think this is for alligators to move, but I'm not sure. The fact that it's wet suggests something that would normally climb over land to get from one side to the other can actually swim underneath it. So imagine there's an alligator on the other side, and the alligator wants to get here. Before they had built this wildlife corridor, the animal, the alligator for example, had to try to crawl over the railroad tracks and get to the side, and they would do it. But quite often they would get caught by the traffic on the road or the railroad, and it would kill them. Now, instead of just letting that happen, if instead you build this wildlife corridor, they will learn, and there's cameras here monitoring it to make sure, but they'll learn, hey, swim through here instead of going over. It's easier, and you don't get killed by a train or by a car. In the Tamiami Trail or Alligator Alley down in the Everglades, they had a lot of, when they first built it, they had a lot of panthers being smashed by cars, because here you had a whole ecosystem in which there weren't any humans, and all of a sudden one day somebody built a road right down the middle of it, and now there's cars going 80 miles an hour back and forth. And the panthers, it's not like somebody sat down and explained it to them. They had to figure it out, and a lot of times the panthers would try to cross the road. And the thing is if there's light coming, you like to cross where you can see. So all of a sudden there's light, so they're like, oh, now's the time to go, I can see. So they run, and that's when they get hit. It turns out is if we build these kinds of holes underneath the roadway, that they'll use these instead of trying to cross the highway, and it had a huge impact. There's a pretty famous picture of the cameras they keep in here, and there were 3 panthers, a couple of other smaller animals, just in that one small area, using that wildlife corridor, and it showed the success that came with this type of thinking. Another thing is to monitor biodiversity hotspots. There are a lot of places on the earth in which the biodiversity is challenged, not just one species, but the biodiversity of the entire region is challenged because of what's happening. And the Amazon is a huge hotspot. Central Africa is a huge hotspot. The Everglades are a huge hotspot. And so if we take a look at these things as a whole ecosystem and we start spending money on them, it helps us to maybe preserve them and preserve the biodiversity. And it works. Look, I don't know if you can tell, but I think that's houses back over there, right? So here is all these houses. Now they're all going to be creating pollution and damage the ecosystem and taking away habitat for animals that live there. So those animals come out here, puts more pressure out here. It all has an effect on each other. But if we can stop that from being so extreme, then this ecosystem can learn to live with it, and after a while the ecosystem will thrive yet again. But these places, these hotspots of biodiversity, are ones that have to be very clearly monitored and watched. And you can't just let people do whatever they want to, because I promise you, if somebody wants to build a house right there, because it was probably a beautiful spot, but that house, and getting the goods and services there, dealing with the waste that house produces, building a road to there, it would cause some real problems for this ecosystem. So instead, we take these hot spots and we preserve them. And very important thing to be doing for these biological hotspots. Restoring biodiversity is what you do when you find a place that's been heavily damaged. And and that's caused usually by human overuse. And that's easy to stop. You just say, okay, it's now illegal to use this anymore, and then that tends to work, because the next thing you know, the ecosystem recovers because people aren't allowed to use it anymore. Or it's no longer legal to hunt these animals because you've hunted them to the point where they've gotten low. The Florida bear, for example, you have to have a tag to shoot a bear in the state of Florida, and they don't give out that many, so they conserve the bear population. And actually, up around the Panhandle, up north of Tallahassee and stuff, the bear population was getting so out of control that they decided to have a one-day expanded hunt, and you could go kill a bear if you wanted. Well, they were planning on doing it for an entire hunting season, but as it turns out, they shut it down after 2 days because they were killing so many bears. Okay, no big deal. We didn't exactly drop the population down to a critical level, but we did let the bear population, we kind of harvested the bear population down to where it's healthy again, and it's also safe for humans. So there's all kinds of things like that that are going on. Another example is this thing called bioremediation. Now this is a concrete tub. It's huge. I don't have any idea how deep it is, but they built this tub, okay, and this dirt was not in it, and this dirt was at a place where somebody had dumped, either on purpose or by accident, an amount of pollution. So they got all this dirt up, they brought it here, and they dumped it into this big tank. Okay, so now the pollution will stay here and not leave, and then you put these amazing plants and other types of organisms in there that slowly start to digest the pollution, and given enough time, this will clean itself up. Now it's going to take 20, 30, 40, 50, 60 years, but at least it's not raining or soaking into the rest of the ecosystem. It's here, it's contained, and they're working on it, and that's called bioremediation, which is where we're trying to help a damaged ecosystem recover. Biological augmentation is another great example of what's going on here, because this is where we kind of play God almost, because we look around and we say, okay, something's going on with this ecosystem. The predator-prey relationship got damaged because the predator got killed off, or the prey got killed off. And so we look around the world and we say, all right, well, what can we do? Here in Hawaii, the pest population was getting out of control because the main predators were being killed. So what do? You go to Cuba and you get a cane toad, or a bunch of them, and you take them out there and you let them go, and then now they are helping keep the pest population out of control. Now this is dangerous, because you really don't know what's going to happen with the cane toads. Cane toads here in Florida are a huge problem, but out there apparently they've integrated themselves into the ecosystem, and they're doing what they're supposed to do, and the ecosystem's getting healthier. Another one is reforestation, an area that's been deforested through a fire or a drought or a flood, or humans doing what humans do. Buy the land, or tell people they have to stop using land, and just let it go to where it'll start fixing itself, and you can actually help that along by planting trees. When you plant trees, you are helping it. It's getting what we can do by 1 weekend planting 10,000 trees would take the ecosystem naturally hundreds of years to fix. So planting trees is a very useful thing to do. It's really one of the best ways to conserve biodiversity. So this is the African penguin. Now, I love these stories of how these organisms are being threatened and they come back, and there's tons. Heck, we got 10 or 15 here just in Florida. The alligator is a great example. But it's always cool to go kind of somewhere else and just see a different one. But they all have this kind of the same story. Something was causing them their numbers to drop. Usually it was human intervention, just like with this guy. Now this is the African penguin. It actually lives on the coast of Africa. It was being hunted down because their eggs are good eating, apparently. So humans would go grab their eggs and eat them, but that was causing a real drop in their population. They stopped that, but now there's poisons and chemicals in the environments that are causing them to struggle as well. So we now have a population that's down 10% what it was at the beginning of the 20th century, just 100 and something years ago. There's only 10% of what it was left. So what do? Well, it's time to start make it a big thing. If you go to collect eggs or their poop for fertilizer, a lot of people use it for fertilizer. That's highly illegal, and we're talking about go to jail for a long time kind of stuff. The areas that they breed along the shores of Africa are protected as national parks and nature reserves. If you're trying to drive a big tanker of oil around, you can't get close to this thing for fear that it could, you could crash, and the oil would pretty much destroy what's left of the African penguin population. This is how we conserve these organisms, is by doing this simple little things. We just think about it. We identify it, then we monitor it, and then we say, okay, their numbers are dropping and we need to take care of it. So we make all these big plans and we do these things to help conserve this biodiversity. Okay, go back, read through it again, grab your notes and start doing some of the assignments that are in there. You notice I skipped them. And this is it. That's the last video I have to produce for you guys. It's been a great year. Keep watching for more instructions, and I will see you at the EOC. Get to work.